right, so on the quiz tomorrow, let's say you see a slope field differential equation problem, which you obviously know is going to be on there. You could see it that way. You could also see some of those multiple choice questions where I say, which of the following could have this slope field? Which of the following? All right, so this will know. Sketch a slope field. So what do you guys get? When y is 1, we expect the slopes to be 0? Yes. When y is 1, 1 minus 1, 0. Wipes the whole thing out, 0. Slopes to 0. How about when y is 0? Well, this is going to be 1 times, what's the cosine of 0? Cosine of 0 is 1. 1 times 1? 1. So you should have slopes of 1 when y is 0. Yes? I'm getting confused looks. Does this make sense? One person said yes.
Yes. Yeah, because if x is negative 1, it'll be negative pi.
Didn't I plug in 0 for... Oh, I plugged in 0. I'm sorry. That's why you're giving me weird looks. X is... I plugged in 0. You know what I did? Just to correct it up here. I plugged in 0 for I was saying that was a y. It's an x. Okay. So we have to do some work here. All right. So for this point right here, for negative 1, 0, we get a positive 1 out of the first set of parentheses. And then we have the cosine of negative pi. What's the cosine of, let's see, for you guys, here's 0. Cosine of negative pi is the same as cosine of positive pi. What's the cosine of pi? Negative 1. Okay. So we end up with a slope of negative 1 at that individual point, negative 1, 0. The next point we're going to plug in is 0, 0. We still get a positive 1 out of the first set of parentheses, correct? And the cosine of 0 is 1. So we're going to graph a slope of 1 at 0, 0. How about at 1, 0? Well, I still have a 1 out of the first set of parentheses, and I get cosine of pi. Cosine of pi is negative 1. So again, I get a slope of negative 1. All right. Negative 1, negative 1. Negative 1, negative 1. All right. What do I get out of the first set of parentheses? Well, a negative 1 minus 1 is negative 2 squared is 4. So for this is why I like to go kind of row by row or column by column, depending on the problem. I'll have a 4 in that set of parentheses when y is negative 1. All right. And then for this specific point, cosine of negative pi. Good. 4 times negative 1. Negative 4, just a slope. It's negative, it's a little steeper than the first one. How about at 0, negative 1? How about at 0, negative 1? What do we get? 4. How about at 1, negative 1? Negative 4, right? There's your slope field. Next, find the particular solution. All right, first step, separate the variables. Did you get 1 over y minus 1 quantity squared dy equals cosine of pi x dx? 2ln or not 2ln? No. All right, so we want to treat that as a y minus 1 to the negative 2 My freshman didn't know about decks of cards. It's okay. I'm not criticizing you. Just I had to take a screenshot of a deck of cards. Then they asked if they learned if they could count cards, or they wanted to learn how to count cards. I said, wait till after the test. No. Maybe. All right. Antiderivative time. Is this as simple as adding 1 to the exponent and dividing by the new exponent? Can I use the power rule? Or do you not know? So yeah? Well, let's... How can we check it? Take the derivative. Ready? -1 times -1. Leave the inside alone. To the... It works. It works. Now, what if there was like a 2y inside? You may have to adjust for that constant. But if it's just a y inside, it's just a simple power rule. Right? Do you guys get that? All right. Do we know the antiderivative of cosine pi x, or would you need a u substitution here? What if you guessed sine pi x plus c? The derivative of this would be cosine pi x times pi. I don't have a pi. Put 1 over pi. I don't think you need u substitution there. If it makes you comfortable, okay, if it allows you to sleep at night, understand. You ready to solve for y? You all right, Gavin? Checking the latest trades.
Well, I've seen it. Brown's got Deshaun Watson yet.
I'm sure you were. When's the meeting? Huh? Oh, it was yesterday. Yeah, we won't hear for a while. All right, plug in 1, 0. All right. 0 for y. So we get 1 equals 1 over pi. Oops, I plugged in. Yeah. No, I plugged in 0 for y. Good. Plug in 1 for x. What's the sine of pi? Oh my gosh, people. It shouldn't take... Thank you. It should not take that long. So c is 1. C is 1. Back to the story. -1 over y minus 1 equals 1 pi sine of pi x plus 1. Guys got it? We solve from here? -1 equals y minus 1 times 1 over pi sine of pi x plus 1. Divide. Add 1. I'm just going to have to take that as an answer because I'm not cleaning that up. Done.
So I still got the same c value, but didn't have the 1 over pi. And I'm just confused with constant. And where'd the 1 over pi come from? Like, that's what I'm mostly confused about.
So did you just get the antiderivative of sine of pi x plus c?
Yeah.
How can you check that?
Take the derivative of it.
Let's take the derivative of it. What's the derivative of sine of pi x?
Cosine. Of pi x.
Times,
Derivative of pi x.
which is?
Derivative of x.
What's the derivative? Like, what if it was 5x?
5.
It'd be 5. Pi x. Is there a pi up here?
No.
No, so it must have gone away, right? And if it was times 5 or times 2, we'd get rid of it with 1/2 or 1/5, right? We have to get rid of it with a 1 pi, okay? So we multiply by 1 pi out front.
Is that a real thing?
It is now. The whole computer language of Python is actually came from the reverse chain rule of integration of this exact function. Python on the computer. Python. Let's call it Python. Yeah, snakes as well. Okay. All right. You serious? All right. Do you want to go over this one? A. Use the line tangent to the graph of y equals f of t at t equals 0 to approximate the amount of the substance remaining at time t equals 2 seconds. All right, so first of all, during the chemical reaction, the function f of t models the amount. So f of t is the amount of the substance present in grams, right? At the start of the reaction, there are 10 grams. Now, I'm going to be honest with you, okay? This worksheet, this was to like challenge you in AP context, this type of problem. The problems you're going to see on the quiz tomorrow are going to be more along the lines of solve the separable differential equation, show a slope field, okay? Find the antiderivative, and I won't say using u substitution, but you'll be like, oh yeah, I need u substitution here. This is more of an application of this kind of stuff. This is not going to be on the quiz tomorrow. This is a AP free response question. Okay, this was not intended as a quiz review. These were problems to kind of model some of this. Now, as we get into section 7.1, 7.1, I've already taught you. Remember how I said how much oil is in the tank at t equals 2? Oh, well, I need to find out how much has been poured into the tank plus how much was there to start. Remember that? That's 7.1. Spoiler. You've already learned it. All right? So this is more along those lines, kind of. Did you read it and say, oh, there are 10 grams to start. Ooh, initial amount plus whatever. Now we're going to see if they're going to ask us that. Use the line tangent to the graph. So as soon as I read that, I'm thinking, if I'm going to write the tangent line, I need a slope and I need a point. Well, they gave me dy dx, okay, and I need a point at 0. Okay. Do I have a point? Well, at 0, do I have an amount? What is it? 10. Do I have a slope? Well, the slope at 0 is when x is 0. The slope at 0, I could also plug in 10 for y, right? Here's the dy dx. What's 10 squared? 100 times negative 0.02. What is it? Negative 2. Okay, so y minus 10 equals negative 2, x minus 0, which is just x. Use the tangent line to approximate the amount of substance remaining at t equals 2. Oops, I put x. My bad. Should be what? T. Well, isn't this y equals negative 2t plus 10? So when t equals 2, what's the amount? Using the tangent line, not using the antiderivative function, using the tangent line. Ooh, linear approximation. Remember that? Plug in t equals 2, negative 2 times 2, negative 4, plus 10, 6 grams? There's approximately 6 grams present. Now they actually want us to find the antiderivative function. Okay, separate the variables. 1 over negative 0.02y squared dy equals dt. Now, you could have chosen to leave the negative 0.02 on this side, right? You could have done that. How many of you did that? Would you like me to do that instead? I'm a man of the people. I'll do that for you. All right, so we have y to the negative 2 dy equals negative 0.02 dt. We have negative 1 over y is the antiderivative. We have negative 0.02 t plus a constant. Let's solve for the constant. We got the 0.010. So negative 1/10 equals c. Plug in 0 for t. C is negative 1/10. So our function is negative 1 over y equals negative 0.02 t minus a tenth. Cross multiply, divide. Can I do a couple steps at once? Y equals negative 1 over negative 0.02 t minus a tenth. Multiplied by y, divided by the junk next to it. Some might say the goop next to it. Okay. It gets the name because it's a little goopy. And there you go. Could you clean it up a bit? Sure. Am I going to? No. If this is an AP problem, absolutely leave it messy, okay? Anybody who chooses to go in the summer to grade seniors' AP tests is a little sick, okay? And probably wants an answer like that. Give it to them, all right? That's what they want. That's what they want. I get chills just thinking about having to grade like tons of AP tests in the summer.
Voluntarily does that.
Hmm?
Mr. Hooper, who voluntarily does that?
Mr. Hooper, Mrs. Case.
Yikes. That sounds awful.
They're great people. I highly respect them. I don't judge anybody who chooses to do that in the summer.
It just sounds like pure pain.
All right. How long will it take the sample of this element to decay to 70% of the initial amount? So are we putting 0.7 why not or 0.3 why not? 0.7 why not? So 0.7 why not equals why not e to the negative point. Is that negative 0.24? Here's what you're going to do on the quiz. Cancel the why nots. L on both sides. You have to show this work, all right? We have a little deal going on here. I didn't put any calculus on this problem. Show me the work, all right? What's ln E? 1. So T is ln of 0.7 over negative 0.24. That is your answer in years. You will not have a calculator. This is how you're going to have to write your answer. How are we doing on those? Don't just hope I don't put one of those on there. It's going to be on there. All right? Solve it like that. Don't mess around. Mason.
Can we skip from step 1 to 3, or do we have to put the ln e to the negative 0.24t? Or can we just put it like it is in the third line?
If you skipped from 1 to 4, I would have an issue. 1 to 3, I'd be okay with. Let's go. All right, what if it asks for half-life? Well, you're going to put 0.5 y naught, or even better, 1/2 y naught equals y naught e to the negative 0.24 t. ln 1/2 equals ln e to the negative 0.24 t. That comes down. Remember, this is ln 1 minus ln 2. ln 1 minus ln 2. ln 1 is 0 minus ln 2. So negative ln 2 over negative 0.24. T is ln 2 over 0.24. Now, I know it's ln 2 over k. I know it's ln of 2 over k. You have to show the work. I know half-life is ln of 2 over k. That's an easy way to check your answer. ln of 2 over negative 0.24. Remember, k is the value. So technically, this is negative k, right? Negative k, because it's a decay function. ln of 2 over 0.24. Questions on that? Excellent. All right. If you're looking for practice problems, I'm not giving you a practice quiz on this. All right, you guys can study. For separable differential equations, go back to the types of problems we've done in the notes, in the homework, in practice. When you separate the variables, anything that can be done with an antiderivative or a u substitution is fair game. All right, you've seen a lot of variety. It's on you to go back and to study those. I'm just warning you. These can get really ugly if you're not confident in the process, okay? So don't just if you've been kind of slacking off with the homework or trying it and you haven't been going back and correcting them as you get them wrong, I would highly recommend doing that tonight, all right? Don't just cross your fingers coming in hoping it's just gonna magically appear on the paper. These are 8 and 10 point questions. And if you are I just didn't know the antiderivative, that's not okay. You will get a ton of points counted off if you don't know the antiderivatives. I've been trying to help you along the way, practice that, reinforce it, a bunch of different types of problems. You can't be sitting there at your paper second guessing which rule you should use. It needs to be automatic tomorrow. Do you understand that? Now, what isn't necessarily going to be automatic? Well, a u substitution. I don't know that you're there yet, where you look at a problem and know exactly what to let u equal and exactly what to adjust for. It's probably going to be here's where you should be, a very educated guess with a check. A very educated guess. You should know what to let u equal. Just as a quick exercise. Number 5, what would you let u equal? The inside, right? Next, what would you let u equal? The inside. The inside. The inside. The inside. The inside. The denominator is inside. Same. And I haven't done any of these problems, just be honest, okay? But this is what you should be able to do. How about this one? The inside. Ooh, not that. The inside, and look, you should be able to predict what's the du going to be. Well, the 1 goes away. What's the derivative of 1 over t? No, derivative, the du. If you let u equal 1 plus 1 over t, what's the du? Derivative. It could be a quotient rule, but don't do that. But that's the best answer so far. T to the negative 1, take the derivative. Negative 1, t to the negative 2, negative 1 over t squared. Oh, look, 1 over t squared. That's a good substitution. Okay, and I know I kind of sprung that on you, just asking these questions. But if that's another thing. If you are accidentally taking derivatives when you should be taking antiderivatives and vice versa, it's ugly quick. All right, let's keep this game rolling. All right, inside. inside, 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 inside. Denominator's inside. These are getting boring. Okay, moving along. 31. Pi x, just pi x. Okay. 33. Radical x inside of sine. And what's the du going to be? What's the derivative of radical x? 1 over 2 radical x. Right? 1/2 of the 7 subtract 1 of the exponent. Oh, that negative exponent goes down. Okay, 1 over 2 radical x. Oh, look, I have a 1 over radical x. Adjust with a 2 to get rid of that 1/2, right? $35. Okay, what's the derivative? 2. I'd have sine of u, cosine u. Do I know that antiderivative? Sine of u, cosine of u. No. Try again. Sine of 2x. What's the du? Cosine 2x times 2. I can adjust for that too. Do you see the game? You have to predict what to let u equal. Okay? Let's go down to 39. 9x. Next one. Can you guys read that? X squared plus 2x. What's the derivative? 2x plus 2. It's not quite right, but a 2x plus 2 is the same as 2 times an x plus 1. I can adjust for that too. With me? Another thing that comes up. Should I ever, or is there ever a scenario where I should let u equal x? What's that going to do for you? All you're doing is making the same problem with a u instead of an x. It's not helping you. All right?
Helps time.
43 is a little rough. I haven't done it yet, but my inkling, what I think people would try, and then it's not going to quite work out for you, is what if you let e equal, or would anybody let u equal e to the 2x? The whole thing e to the 2x? The du would be e to the 2x times 2. But I don't have an e to the 2x times 2 dx. I have a subtraction there. You probably want to do some algebra first. You probably want to rewrite it as 5 over e to the 2x minus e to the x over e to the 2x. And do them separately. This can be thought of as 5e to the negative 2x, which you could do a little u substitution on. This is going to get messy. What's e to the x over e to the 2x? What is it?
E to the x.
In the numerator or denominator? 1 over e to the x? Do you know? Do you not know? All right. Because e to the 2x is e to the x times e to the x, isn't it? It's e to the x times e to the x. It's e to the 2x. One of those e to the x's cancel. I have one more left in the denominator. That was a little spicy. All right, let's keep going. 34. Let u equal. What's a theta? 1 over theta? What's the du? Negative 1 over theta squared. Ooh, we're off by a negative. That's good. I like it. It's close. 36. Let u equal. Derivative is secant squared x dx. Perfect. All right, and so forth. All right. I'll be happy to go over those in just a minute. Any of those you'd like to see. These ones all had the answers next to them. They weren't in red for you, but if you saw some weird numbers. Huh?
I was looking at it thinking that they were like all the same problem. I didn't do it because
Oh. Sorry, it didn't come out very clear on yours.
like they look the same color.
You are right. Those are all answers.
Okay.
I would like to do a couple problems with you guys.
Alrighty.
Would you like to pick any? Let's pick a couple from 5 through 50, and then one or two from the bottom group with bounds. What do you want to do? And I know different people tried different problems. Okay, that's okay. If there's any you'd like to see worked out, we can do it. I guess my job's here done. My job here is done. Lane.
16. Crazy.
Spicy.
2 and 4.
Should I do Y?
This is where I need to, I guess we gotta see each other.
Yeah. All right. Lane. What did you let P equal? Or what kind of stuff? What letter did you use for your assumptions?
I didn't see.
Didn't know how to do it.
No. Yeah.
They took U, so that's out. Beta? Which one you say? X? We'll get them now. Let X equal U cubed plus 2. Let's test your understanding of calculus. What's the derivative called? D blank, and I'm actually not going to multiply the thing over right away. I'm going to test your understanding. D blank. I hear dx, du. Do you agree? What is it? 3u squared. Multiply the du over. So dx equals 3u squared du. Do we agree? Well, do I have a 3u squared du? No, I've got a negative 2u du. How do I turn a 3 into a negative 2? Do you want the math for dummies approach, or do you want a Chad approach? What's Chad? Is that like a sweaty student? Is that what the students call?
Yeah, you got it.
Sweaty?
It's like,
Is it the right context?
Just better than everybody.
Not really.
It's superior.
It's on the right track.
What would you multiply 3 by to make it a negative 2? Negative 2/3. Let's see. Bless you.
Thank you.
I multiply both sides by negative 2/3. The 3's cancel, and I just turned that 3 into a negative 2u squared du. The math for dummies approach, okay? Dummies being like when you go to the bookstore and you see you go to Borders and you Books a Million, is that what it is? Can I tell you an embarrassing story? I don't read much. I don't read much let me grab a book and read it. Informational text I will read a lot of, okay? Fiction, no. So someone got me a gift card for Christmas one year. It was years ago. It was to BAM, okay? And I took it over to that. My wife and I are going out, okay? And we happened to be eating healthy that night, so we go over to this Washington Square, and there's BAM healthy cuisine, right? Go up, order, and them a gift card. They're like, this is for Books a Million. I'm like, what? It says BAM. Yeah, I should have bookstore. Then it made me doubly sad to think of the person who got it for me actually thought I was going to use a bookstore gift card. You know?
You ever use it?
Yeah. Well, I think I did. I probably bought my wife something. Where was I going with that? Oh, Math for Dummies. Okay, you go to a bookstore. You know how like when you buy one of those for dummies books on Amazon? You know, do your parents ever do that? Like taxes for dummies. Like you buy it in an endearing way. Like you're not like, oh, I'm an idiot. Like, how do I get this? Like you know that you need help with it, right? So I'm not trying to offend you, but the Math for Dummies approach to this would be to divide both sides by 3 first. So a third dx equals u squared du, and now you can put whatever number there you want. So if you multiply the left side times -2, you multiply the left side times -2, and you'll get the same thing.
Is it bad that I like that one?
No, it's endearing. Sorry, it's the endearing approach. All right, so wherever we see a -2u squared du, we're putting in a -2/3 dx. So here we go. We got a square root. What goes underneath? X does. This is weird. X goes under the square root because x equals u cubed plus 2. And our -2u squared du, -2u squared du turns into -2/3 dx. We know this antiderivative. The -2/3 goes along for the ride. The antiderivative of x to the 1/2 is 2/3 x to the -1/2. Yes, yes. Plus a constant. So we get -4/9. 3/2. Thank you. 3. So we're adding 1 to the exponent. Oh my gosh. My goodness. Math for dummies, here I come. All right. Let's try this again. Can I warn you guys to not take derivatives where you should be taking antiderivatives? Did I warn you about that? Yeah. Yeah. You watch it. All right. So add 1 to 1/2, we get 3/2. Divide by 3/2, we get 2/3. So it's still 2/3, but the exponent should have been 3/2. So the -4/9 was correct. X to the 3/2 plus c. Now, trying to save my pride here, okay? I honestly would be that Chad that checks the answer, checks the derivative to make sure it works out, and it would have.
That's not.
Wait, what? Why would that be Chad? Chad just knows it's right.
Yeah, he's not a dummy. So he knows it's right. He's just like, you just
Confident.
turn it in.
Oh. Is Tyler a Chad?
For real.
Yeah.
For sure. He'd be one of those guys.
I'm starting to get it. I'm starting to get it. Hey, we'll walk down the hallway after this, and on the way I'll point out the Chad. Chad. All right, substitute. I'll just get a Chad for Dummies book after this. X cubed plus 2. Nope. U cubed plus 2.
It's
Can we check it? 3/2 times -4/9 is -12/18. Remember that. -12. I guess you don't have to remember it. I just wrote it down. Times u cubed plus 2 to the 1/2 times 3u squared. What does a 3 combine with to make with -12/18? -2. And what do we have out front? -2. u squared, right? Negative 2 u squared times the square root of the junk inside. And the junk inside was u cubed plus. I highly recommend you check your answer, okay? And I actually made that mistake just to show you how deep I did. I messed up.
Had to be checked.
No, but seriously, a quick check like that doesn't take long, and you can avoid some of those mistakes. Was that Don that asked that one? No, it was Lane. Lane, do you feel good about that?
Yes.
Awesome. Others, Casey.
It's just a question. Do we have to do the weird adjust for LM thing where it's negative or positive? We need to test it.
Yeah. Definitely.
I'm not gonna be very much.
What's that?
I said I'm not gonna be doing much. Skipping school.
You're gonna go hide out in the Spanish room?
Sure.
Cool.
Can we do 37?
Is it spicy?
Yeah.
Sure. All right. Avoid taking expressions with their exponent. That just introduces a chain rule that may be unnecessary. Okay. So what would your first guess be at u substitution? Cotangent x? All right. Do you agree this is a cotangent x cubed? So if we're going to let u equal cotangent x, what's du? Negative cosecant squared x dx. Well, we've got a positive cosecant squared x dx. That's good. So a negative du will make that negative positive, won't it? So we're going to have an integral. Now, here's the important part. You guys have to get this. We've been doing this for a while. What goes where? Well, the cosecant squared x dx becomes a negative, and put the negative out front, du. What goes where? Tom.
Would it be 1 over u to the third?
Good. It's 1, placeholder of 1. Do you guys agree that u's in the denominator being cubed? Right? To ln? Or not to ln? Oh, you guys are good at this game. Have you been practicing the game? So we have negative u to the negative 3. No antiderivatives have been done yet. Add 1 to the exponent. Be careful. When you add 1 to negative 3, you get negative 2 and divide by the new exponent. So we get negative u to the negative 2 over negative 2. So really, let's write it clean. What's it going to be? Positive 1 over 2u squared. Where u is cotangent x, or you can put 1 over 2 cotangent squared plus c. Did I mention you'll miss a point if you don't put plus c? Beautiful. It's a beautiful problem. Cool. Feel better about that? Questions about the quiz tomorrow? We're at that time where we need to just take a step back, reflect. We know what's going to be on the quiz. Got some slope fields.
I'm ready too.
Khan Academy has a good practice unit on matching slope fields to the correct function if you'd like extra practice. All right? Slope fields, U substitution, separable differential equations. Last question for you. If you see a problem like these ones right here, with bounds, your final answer is going to be a number. Should you ever go back to x's? No, stay with the u's. Don't forget your u bounds. Plug in the top bound, plug in the lower bound, subtract. Final answer is a number. I hope you all have a wonderful day.